Now I will tell you the one mark question also. Page number 49. The characteristics of first point 3 1 mark question. General electronic configuration for p block elements NS2 NP 1 2 6 because 13th group anomalous NS2 NP 1 2 3 4 5. So the general electronic configuration for p block elements NS2 NP 1 2 6. Then is potash alum formula. 1 mark question. Then the next question. But it is 5 mark. Yeah. Sixth uses. Tetraethyl lead is used for additive to petrol to prevent anti-knocking. This anti-knocking agent, tetraethyl lead. Now, very important question, anomalous nature of fluorine. Anomalous nature of fluorine. You know the halogens, halogen series. Anomalous nature of fluorine. You know the halogen series. The 17th group elements are known as halogens. In the 17th group, fluorine, chlorine, bromine, iodine, astatine. Astatine present in the 17th group, but that's not a halogen. That's a radioactive element. So that only purely 4 only halogens, namely fluorine, chlorine, bromine and iodine. Fluorine is somewhat different from other halides. Fluorine is somewhat different from other halides. That's why we are studying anomalous nature of fluorine. Anomalous nature of fluorine. Fluorine is a highly reactive element. Fluorine is highly reactive among the halogen. Why mean? Because of F bond dissociation energy is very less. Okay, among the halogen, fluorine is a very reactive element because of that F bond F. You can dissociate very easily because of F of bond dissociation energy is very less. Very less means you can remove very easily. We can dissociate very easily. It reacts very fast with other elements. The second point. Fluorine decomposes with cold dilute alkali, it gives oxyfluoride. Very same thing, the concentrated alkali mean oxygen is liberated. Under similar conditions, other halogens, it gives to hypohalite and halates. It has great affinity with hydrogen, so that it forms HF. Okay. HF gives intermolecular hydrogen bonding. HF is a very weak acid. HF attacks glass. The last question, dash attacks glass. Because fluorine has very greatest affinity with hydrogen, resulting to form a HF bond. Okay, HF gives intermolecular hydrogen bond. Finally, you will get HF. HF attacks glass. Okay. Oh yes. You know what is HF? Already we discussed first lesson itself. HF mean this is a one hydrofluoric acid. This is another hydrofluoric acid. Now intermolecular hydrogen bond mean this H bond with F. Okay. So this is intermolecular hydrogen bonding. It differs markedly from other halogens in that it can form two types of salt with metal, namely sodium fluoride and sodium hydrogen fluoride. Okay, it reacts with metal. It gives two different types of salt, namely sodium fluoride and sodium hydrogen fluoride. Then the salt of HF differs from other halogens. Other hydroxides, AgF is soluble in water, other AgX are insoluble. Listen ma, AgF alone soluble in water, other AgCl, AgBr, AgI and all insoluble, because X mean halogen. X mean what? Halogen. So AgF is soluble in water, other AgX are insoluble in water. Then being strongly electronegative part, it have only negative oxidation state. Okay, fluorine oxidation state -1. What about other halogens? Maybe plus or minus. Maybe plus or minus. HF attacks glass, others do not. Fluorine, because of absence of d orbital in its valence shell, does not form any polyhalides, but others have I3 minus, Br3 minus and Cl3 minus. But fluorine alone, there is no any polyhalides. Fluorine alone there is no any. Why? Because of absence of d orbital. Clear? These indicate anomalous nature of fluorine. So fluorine is somewhat different from other halogens. Fluorine is highly reactive element among the halogen because of the bond dissociation energy is very less. Then fluorine decomposes cold dilute alkali. It gives oxygen and oxyfluoride. It has greatest affinity with hydrogen, resulting to form a HF. Okay, HF means another intermolecular hydrogen bond takes place. It differs markedly. Other halogens, it differs markedly from other halogens because it gives two types of salt, namely sodium fluoride and sodium hypofluoride. The salt of AgF is soluble, other AgX are insoluble in water. Being an electronegative part, fluorine oxidation number is oxidation state is negative oxidation state, but other halogens may be plus or minus, positive as well as negative oxidation state possible. HF attacks glass, others do not. F3 minus form F3 minus. There is no polyhalide because of absence of d orbital, but others form polyhalide, namely Cl3 minus, Br3 minus, I3 minus available. There is no F3 minus. Clear? This indicate fluorine is somewhat different from other halides. Now, how to isolate fluorine? That named as Dennis method. They can ask in two different ways. They can ask question directly, mean explain Dennis method. Otherwise, explain Dennis method one of the another way. How to isolate fluorine? How to isolate fluorine? The process named as Dennis method. This method is devised by who? Dennis method. Devised by who? Dennis, Wieder and Recho. This fluorine is prepared from electrolysis of fused sodium or potassium hydrogen fluoride. Okay. Fluorine is isolated from sodium or potassium hydrogen fluoride in fused state. Okay. Now electrolysis carried out in between the graphite electrode. Initially we are going to take V shape electrically copper tube. Here only we are going to take the fused potassium hydrogen fluoride. We are going to take graphite electrode, then it is closed by backlight, cement Okay. It is covered by one more outer jacket to prevent loss of heat. Okay. Now it's a U shape. This contains NaF, sodium fluoride. Sodium fluoride. Here we are going to pass what? Hydrogen. What? Hydrogen. Here electrolysis takes place. Which reaction takes place? Electrolysis reaction takes place. So what type of reaction? Listen, ma'am. Potassium hydrogen fluoride undergoes electrolysis. It gives KF and HF. KF and HF. Now this hydrogen fluoride will decompose. It gives H plus and F minus. H plus and F minus. Now H plus, 2 molecules H plus, 2 plus is there, 2 plus. How to remove 2 plus? You have to add 2 electrons. Addition of 2 electron. So it will become a H2. Clear? Become a H2. Now F minus. F, I am going to take 2 molecules of F minus. Now you have 2 minus extra. How to remove 2 minus? Remove 2 electron. Remove 2 electron. So minus 2 electron. Become a, you know what is oxidation reduction as per electronic concept? Removal of electron nothing but what? Removal of electron nothing but, very good, oxidation. Addition of electron nothing but reduction. Removal of electron mean oxidation. Addition of electron mean reduction. Okay. Where oxidation takes place, where reduction takes place? In anode or cathode? Always in anode oxidation takes place. In anode oxidation. Cathode, anode oxidation, cathode reduction. Anode, cathode reduction. Okay, here what type of reaction takes place? Here addition or removal of electron. So addition of electron nothing but oxidation or reduction? Reduction. So reduction reaction takes place whether it is anode or cathode. So this reaction takes place in cathode. Clear? Here is a removal of electron. Removal of electron is oxidation or reduction? Oxidation reaction. Very good. Oxidation reaction takes place in anode. So this reaction takes place in. Now fluorine is liberated where? Where? In anode mean plus or minus? Anode mean plus or minus? Anode mean plus. Cathode mean minus. Only 2 things you have to remember. Plus and minus. Which one is cation and which one is anion? Plus is cation. Minus is? What is cathode? What is anode? Minus is? Plus is? Okay. So now fluorine liberate where? In anode. That fluorine reacts with see, fluorine liberated in cathode is passed through U tube containing sodium fluoride. This is removed by hydrogen fluoride vapors coming with fluorine. Suppose along with fluorine somewhat few amount of HF also present mean that HF reacts with that NaF, it gives sodium hydrogen fluoride. Now fluorine is liberated at anode. Okay, suppose somewhat very less amount of HF also present along with the fluorine mean that HF react with U tube containing sodium fluoride. It become what? NaHF2. It's very clear. You able to understand? Sir, no? So Dennis method is very important 5-mark question. How to isolate fluorine or explain Dennis method? Anyway they can ask. Okay. Then page number 69, the second uses. Dash is used as flux in metallurgy. CIF2, important 1 mark question. CIF2 used in flux in metallurgy. Then interhalogen compounds. Interhalogen compounds. Any idea about interhalogen compounds? You know halogens? Halogen you know. What is interhalogen compounds? A reaction between different? Very good. Reaction between two different halogens. Okay, reaction between two different halogens. So you know halogens mean the 17th group elements are known as halogens, namely fluorine, chlorine, bromine, iodine. These are the halogens. Interhalogen mean reaction between two halogen. Reaction between two halogen. Maybe fluorine with chlorine, or chlorine with Br, or bromine with iodine, or I with Cl, or Br with F, or I with F. Anyway, reaction between two halides, two halogens. But one condition is there. So intermolecular interhalogen compounds mean in between the halogen takes place reaction. That is interhalogen compounds. That is so many types. First one is AX type, then AX3 type, AX5 type, AX7 type. Initially AX type, AX type. That means one of the halogen is A, another halogen think about X. So AX. Clear? For example, chlorine reacts with fluorine. Now think about these two halides going to react. Now as per rule, first you have to write, you know what is electron affinity or electronegativity? In the halogen series, going down the group, electronegativity, negativity decreases. Electronegativity decreases. As per rule, you have to write first less electronegative element. Suppose fluorine and chlorine going to react mean, what will come first in the product? ClF, not FCl. Clear? Suppose F with Br mean? BRF, not FBr. Br with Cl mean? Br with I mean? I with Cl mean? ICl or CLI? F with I mean? Clear? Now chlorine reacts with fluorine. What's the product now? Two molecules of ClF. Okay. Now chlorine reacts with bromine. Two molecules of BrCl. Okay. Now chlorine reacts with iodine. ICl. Okay. Clear? So any two halogen going to react, out of these two halogen, which one have less electronegative part, that you have tried initially first. That's a product, that's a rule. These are AX type, AX type. So many types possible: AX type, AX3, AX5, AX7. Very same thing. Second halogen 3 times mean, that is AX3 type. Second halogen 5 type mean AX5 type. 7 type mean AX7 type. Now we will discuss detailedly how AX will form, how AX3 will form, how AX5 and AX7. They will ask 5 mark question, explain AX and AX3 or AX3 and 5 or 5, any two they will ask in 5 mark question. Okay. Explain how interhalogen compounds will form, X band AX type and AX 5 type, any two they will ask. Initially we are going to discuss about AX type. Think about A is one of the halogen, X is the another halogen. Okay, A one halogen, X is the another halogen. Just think about very easiest example. What you want? ClF. So take ClF. Because that will be first form now. Fluorine, chlorine, bromine, iodine. First we will discuss about Cl2 and F2 plus Cl2 it gives 2 ClF. Am I correct? F2 plus Cl2 it gives 2 ClF. That's a linear compound. Okay. So your AX with the example ClF. Chlorine. Atomic number of chlorine 17. So electronic configuration. I am not asking else electron. Chlorine atomic number is 17. So according to Alpha principle, 1s2, 2s2, 2p6, 3s2, 3p6. Atomic 17. Okay, 10. So 2p 5. Neon 3s2 3p5 is electronic configuration. Clear? Neon 3s2 3p5. Now 3s, this is 3p. 3s split into only one. But your textbook given one circle. Don't afraid of that one. The given is instead of your usual shape, the given one circle. Okay. Okay. Yes. This yes. Yes, orbital, how many electrons you have? 2 electrons. P split into 3 types, X, Y, Z. X, Y, Z. So, see X orbital, Y orbital, Z orbital. Okay. How many electrons you have already? 5 electrons you have. Each and every orbital you can fill maximum how many electrons? 2 electrons. So, as per according to Hund's rule, you can fill initially 1 electrons, isn't it? No pairing occurs until all the orbitals are singly occupied. So you have 5 electrons. So 1, 2, 3, 4, 5. Isn't it? This is a chlorine electronic configuration. Now, how the AX type mean? This is A, that means Cl. Now, how the F will come and join with Cl mean? In the configuration of Cl, one unpaired electron is present. One unpaired electron is present. In that place, that F electron, fluorine atom contains one electron, no? That electron will come and join with the fluorine. This is electron of fluorine. This is electron of chlorine. Now these 2 electrons involved in the bond formation to make a single bond between Cl and F. Because in electronic configuration of chlorine, only one unpaired electron is there. In that place, the fluorine will come and join with chlorine atom to form a ClF molecule. Here, this is only AX type. Which type? AX type. Clear? This is which hybridization mean? What are the orbitals we used? Which orbital? S orbital. Which orbital? How many orbitals we used? So which hybridization? sp3 hybridization. Clear? So AX is which hybridization? sp3 hybridization. Clear? So we go to AX3 type. AX3 type. Very same thing. AX3 type mean ClF3. ClF3. Cl atomic number very same 17. Electronic configuration 3s2 3p. Finally, initially one neon is present. Instead of 1s2 2s2 2p6. 1s2 2s2 2p6. After that 3s to 3p5. Clear? Now 3s2. This is S. 3s. 3p. You want 3d? You want 3d? D split into 5. So 3s, 3p, 3d. How many electrons you have? 2 electrons you have. 1, 2. In p, 5 electrons you have. 1, 2, 3, 4, 5. Okay. Now, how that 3 fluorine will come and join with the fluorine? Any idea? How 3 fluorine going to come and join with chlorine? Any idea? Huh? Listen, ma. In the previous case, it contains only one unpaired electron. So only one unpaired electron permit only one covalent bond. Only one covalent bond. Here, you have to create already how many bonds you need? 3F is present. 3 fluorine atoms present. So how many unpaired electron we need? We need 3 unpaired electron. But how many present? We have only one unpaired electron, that is in ground state. So in excited state we need 3 electrons. Anyway, we have to create, listen ma, these are the 3 guest members going to come to your home. So you have to create at least 3 vacant chair. Then only they will come and sit, they will come and accommodate that place. Isn't it? Okay. Initially we have only one chair. Then how they will come and sit in 3 members? You have to create. Okay. So in excited state, listen ma, it's in ground state. In excited state, very same 3s, p, 1, 2, 3, 1, 2, 3, 4, 5. Okay. Listen, as it is 2 electrons. Here, in excited state, this electron from p orbital goes to here to make a single bond. Now here also single bond, here also single bond, here also single bond. So 3 unpaired electrons present. Now 3 electrons from fluorine, they will come and make with 3 single bond, 3 covalent bond. Clear? So 2 bonds present. Here how many electrons you have? 1 electron, another electron. This electron goes here to make a single electron. Now no problem. You created 3 vacant chair. Now they will come and sit very comfortably. Okay. Now okay. Very same 2 electrons. Here 2 electrons. Here already one electron is present. How many members going to come here? 3. So 3 electrons from fluorine atom. One from here to make a bond. Another 3 things over here. Clear? 1, 2, 3. Now what are the orbitals we used? This is S. P, how many p orbitals? In D, 1. So which hybridization? X3 is sp, 3d hybridization. Which hybridization? sp3d hybridization. Trigonal pi-pyramidal in shape. Trigonal pi-pyramidal in shape. Which shape? Okay. The next one is AX5 and AX7 type. AX5 and AX7 type. Very same thing. AX5 mean, listen ma, AX5. Now how many unpaired electrons you need? 5 you need. So any other way? Huh? This electron also goes to here. So it will become a this also become a single bond. Here will become another single bond. So all here also, then you created how many single bonds? 5 single bonds. So 5 vacant chair is ready. Now very easily they will come and sit in that place. 1, 2, 3, 4, 5. Very same thing, but in the case of which hybridization here? sp3 d2, sp3 d2 hybridization. Octahedral shape. Which shape? Octahedral shape. What about AX7? Pentagonal pi pyramidal shape. How to produce 7 unpaired electrons? Yeah, from this also goes to here. Okay. So 1, 2, 3, 4, 5, 6, 7 unpaired electrons will come. All 7 places. Which part going to come? That part, that electrons will come and join to make a single covalent bond between them. For example, IF7. IF7. Clear? If you have any doubt in interhalogen compounds, if you have any doubt, clear? No doubt. Okay. Very important. I told any two they will ask. Explain AX type or AX5 type or AX3 or AX7 type. Any two they will ask in 5 mark part.